Can you hear me, guys?
Yes.
Okay. Yes, someone is lagging. Yes. Yes, Mariam, can you hear me? She cannot hear me. Mariam, can you hear me?
Yes, I can hear you.
Okay. Okay, so I'm going to take the attendance first.
Yes.
Yes. Can you hear me, guys?
Yes. Yes.
What's wrong with your mics? Ali? Ali is not here. Aisha? Aisha is still connecting. Farida? No. Hala? Sorry, Hannah first.
Yes. Like this, I'm still like.
No, you're fine. Can you hear me, Mariam?
Yes.
Okay. Hala?
Yes.
Haya?
Yes.
Khulud?
Yes.
Nimar?
Here.
Malak?
Here.
Mariam Walid is here. Muhammad is not here. Mustafa is not here. Mustafa just entered. Najat?
Yes.
Noor and Yasin? Noor Tamer and Yasin Tamer?
Yes.
Both of you are here?
Yes.
Okay. Ruqayya?
Here.
Yasin Abdul Hamid?
Here.
Yasin Muhammad Radwan?
Here.
Okay. Aisha is still connecting. Mustafa, did you join us? Huh.
Mustafa's mic isn't working.
Mustafa's work isn't working. Okay. We're going, please mute your mics, guys. Mute your mics, mute your mics, mute your mics, mute your mics. Someone is to mute your mics. And Mariam, mute your mic too. All right, guys. So we're going to continue. We're going to continue where we stopped. We were talking about how can we detect the difference or find out the difference between acids and alkalis. And we said that scientists, starting with a scientist called Robert Boyle, thought about using the fruit and vegetable juices to detect the difference between acids and alkalis. And this worked with him when he used the fruit, the juice of the red cabbage, and he noticed or discovered that when you put acid to the red cabbage juice, the red cabbage juice is purple originally. When you add acid to it, it turns red. And when you add an alkali to it, it turns green. After that, several scientists started to use this idea with different materials, and we named all of the chemical materials that changes its color when it reacts with acids and alkali indicators. So the indicators are a dye or a chemical that has a color, and this color changes whether the solution it reacted with is an acid or an alkali. We call them indicators. Then we said that one of the things that was used is something called litmus, and litmus is the dye of specific flowers. The litmus is originally purple, but sometimes they make out of it two different colors, and those colors are the pink color or the red color and the blue color. Okay. Now, the idea is that how did they make both of those colors? The litmus has actually two main colors, which is the red and the purple. So they started using each one of those colors with different type of chemical. What does that mean? We will know in afterwards that the blue strip or the blue solution of the litmus, because the litmus could be made as a solution or could be made as paper strips. We just add the color to the paper, or we just add the color to water. Okay, so we have two colors of litmus, a red color and a blue color. Okay, now guess what? They found out that the blue color of the litmus, of the litmus, when we add acid to it, it turns red. The blue color of the litmus, when we add acid to it, it turns red. But if you add an alkali to it, the color will remain the same. Okay, so we're talking about only the blue litmus paper. The blue litmus paper, when you add an acid to it, it will turn red. But if you add an alkali to it, it will remain the same. It will not change its color. On the other hand, they found that the red litmus paper, if you add an alkali to it, it will turn blue. But if you added an acid to it, it will remain the same. Okay, so let's repeat it again, or let us now see how the different or the things become different. Now this is the litmus solution. Okay, this is the blue litmus solution. When they added an acid to it, I know it looks a little bit orange, but it's actually in the real thing, it's actually red. When they added an acid to it, it turned red. And when they added an alkali to it, it turned into dark blue, and sometimes it doesn't change its color at all. Okay, so if it's purple, the litmus solution is purple. If you add acid to it, it's going to turn red. If you add an alkali to it, it's going to turn blue. Let's see what will happen with the strips. Okay, the litmus paper. We have the blue litmus paper and we have the red litmus paper. Okay, now I want you to guess before I show you anything. We added to the blue litmus paper a solution and it turned red. What do you think this solution is? Is it an acid or an alkali? Raise your hand if you know the answer. Raise your hand if you know the answer.
Yes, I know.
Raise your hand if you know the answer. we have a blue litmus paper and we added a solution to it and it turned red. What do you think the solution is? Yes, Najat.
It's an acid.
It's an acid, exactly. So the acid will turn the blue litmus paper into red. What about this one? Yes, Noor. It's a red litmus paper and we added a chemical to it. It turned blue. What do you think it is? Is it an alkali or an acid? Noor?
Alkali.
It's an alkali, exactly. So it turned blue. This means that it is an alkali. Okay? Now, and this shows us what will happen. Okay? You have an acidic solution. We have three types of solution: acidic solution, alkaline solution, and neutral solution. Neutral means that it's not acid nor alkali. Like what? Like water. Water is not acidic and not alkaline. Okay, so it's just, we call it neutral. Okay, now my question is, I want someone raise your hand if you want to answer. I want to see the effect of the acidic solution on the red litmus paper and on the blue litmus paper. Hey, on the red litmus paper and on the blue litmus paper. Raise your hand if you want to answer. What is the effect of the acidic solution on the red litmus paper and on the blue litmus paper? Come on, guys, no one knows? What is the effect of, you were just answering this question. Where are you guys? Wake up. The acidic solution, I want to know its effect. Okay, raise your hand. The effect of the acidic solution on the red litmus paper and on the blue litmus paper. How will the litmus paper, it's even drawn up there.
It changes color.
I know. Raise your hand. I want to know how will they affect. Yes, Limar. Hey, if I added the acidic solution to a red litmus paper, is there anything that will happen?
No.
It will remain what?
Red.
Red. But if I put it on a blue litmus paper, what will happen?
It will turn red.
It will turn red. Thank you so much, Limar. So it stays red. If we added an acidic solution to the red litmus paper, it stays red. But if we added the acidic solution to a blue litmus paper, it will turn red. Okay? Now, what about the neutral solution? Neutral solution is like water. If I added water to both of the litmus paper, the red litmus paper and the blue litmus paper, I want you to guess what will happen. The neutral solution, like water, how will it affect the red and the blue litmus paper? Hey, come on, guys. Guess. Are you awake? Did you fall asleep? I'm not talking to you, Noor. I'm talking to the rest. And Limar also raised her hand. Where are the rest? Where are the rest? I'm telling you to guess. Guys, raise your hand. I said the questions like 5 times so far, Hannah. Wake up. Wake up. I am fasting too, by the way. And I dressed up and I came to school and this is the 3rd session that I'm working. I know that you're fasting, but you are at home and you should be awake. If we added the neutral solution, again, what's the meaning of neutral solution? Neutral solution is like water. Water is not acidic and it's not an alkaline. It is not acidic and it is not an alkaline. How will it affect the red and the blue litmus paper? Yes, Khulud.
Will stay the same.
They will stay the same. Thank you so much. The neutral solution will not affect the blue or the red litmus paper because they only react with the acidic and the alkaline solution. Was it so hard to guess, guys? Thank you, Khulud. And the last one, what about the alkaline solution? What will happen when it reacts with the red litmus paper and the blue litmus paper? It's the opposite of the acidic solution. The opposite of the acidic solution. Yes, Hala. What will happen?
The red one
Will turn what?
Turns blue, and the
Yes.
blue one will stay blue.
Thank you so much. The red litmus paper will turn blue, while the blue litmus paper will stay blue. It will not change. Okay, guys? Is it clear? Do you don't understand? Tell me if you don't understand, just tell me to repeat it, but don't stay quiet. Nothing, no one is answering me.
I understand.
I know, Limar, that you're here, and Noor is here, and Hala is here.
Miss,
yes.
I raised my hand for a long time.
And I told you that I'm not talking to you, Noor. Okay. Now, to make like a very simple rule for you guys to so that you don't get confused, I want you to remember the word Arab. We are Arab. I want you to remember this word Arab. What does that mean? It means that A stands for acid, and acid turns the litmus paper red. The other A is alkali, and the alkali turns the litmus paper blue.
Blue.
Yes. So you remember the word Arab. Acid turns the litmus paper red. You start with an acid, okay? Acid turns the litmus paper red, and alkali turns the litmus paper blue, okay? So we don't only have this red cabbage juice and the litmus paper. We actually have over 20 other indicators that we use to identify or to detect the acids and the alkalis. Two of the examples or two of the main chemicals that we use to detect the acids and the alkalis are something called methyl orange, a chemical called methyl orange, and from its name, what do you think its original color? What is its original color?
Orange.
Orange. Its original color is orange. Okay? So when we add an acid to it, it turns pink, it gives this lovely pink color. And if we added an alkali to it, it starts to become lighter and turns into a yellow color. Okay, so what is the name again of this indicator? It's called methyl orange. Methyl orange. And from its name, we know that it is orange originally. When you add an acid to it, it will turn pink. And when you add an alkali to it, it will turn yellow. Okay? The second indicator has a funny name. Its name is phenolphthalein. phenolphthalein. So we call it phenolphthalein. And it has an abbreviation. This is like an extra information. When I was in college, we used to give it an abbreviation because we're not going to write this whole thing. So what do we write? We write PH. Instead of writing phenolphthalein, we use this abbreviation, PH. Phenolphthalein. Okay, so this one is actually, it has this beautiful color, and it reacts with the alkali mainly. This phenolphthalein is actually it has this very dark pink color, and when you add an acid to it, it turns colorless. But when you add an it has this faint pink color. When you add an acid to it, it turns colorless. When you add an alkali to it, it turns dark pink. And I will show you all of this. Don't worry, I will show it to you in the next session, all of this and all the colors. And hopefully when you come back to school, I'm going to take you to the lab and you will try it yourself. All right, so what are the two examples of an indicators? We have the methyl orange, which is originally orange, and when you add an acid to it, it turns pink. When you add an alkali to it, it turns yellow. And the second one is called the phenolphthalein, and the phenolphthalein turns colorless in acid solution, and it turns pink in alkaline solution. Okay?
Okay.
All right, so I want you to open your resource packs, please. I want you to open your resource packs, page 24. Page 24. Page 24. I will open it now. Yes, page 24. Here it is. And if you have some colors, please grab it. If you have some colors, please grab it.
Okay.
Okay, I want some colors, and preferably so that you want.
Miss, does it have to be crayons? Because I have only markers.
You have only what?
Markers.
Markers. I was just saying that please use the crayons or use the pencil colors, because markers and flamaster colors will just stain.
Okay, Miss, I found the stain.
Yes,
When you color it from this side,
it's
you
going
must
to stain.
on the other side.
What?
The pencil or the flamaster or the crayon?
A crayon or a pencil color. Okay, so we're going to start first with question number 1, and then in question number 2, we're going to use the colors. Okay, question number 1, we have words in this box. Those words are changes, extract, acid, color, indicator, and alkali. Okay. Question A says some plants such as red cabbage or black currant can be used to show if a solution is an what or an what. Raise your hand if you want to answer. Hey. Some plants such as red cabbage or black currant can be used to show if a solution is an what or an alkali. Huh? Guys, I have 3 people raising their hands. 4 people now. 4 people now. Yeah, thank God, people are waking up. Ruqay, some plants such as red cabbage or black currant can be used to show if a solution is an what or an alkali?
Acid.
Acid, thank you. Is an acid or an alkali. Question B, we call a substance which can show if a solution is an acid or an alkali and what? And what? Yes, Mariam.
Indicator.
Indicator. Excellent. Indicator. Thank you, Mary. Question C. We make these indicators by taking out the juice from a fruit or vegetable. This juice is called an what? Because it has been extracted from the plant. Look at the box and choose the word. It's already written in the statement. We make these indicators by taking out the juice from a fruit or vegetable. This juice is called an what? Because it has been extracted from the plants. Yes, Hala.
Extract.
Extract, thank you. We call it an extract. Next is question D. The extract is a substance which becomes a different what in an acid from the color it is in an alkali. A different what? Yasin Abdul Hamid. Yasin Abdul Hamid.
Yes, can I say it?
Color.
A different what?
He's saying color.
Color. Yes, a different color. Very good. The last one, litmus is another indicator which what color in an acid solution compared to an alkali solution. It does what? What happens to its color when it's in an acid solution compared to an alkali? Yes, Hannah.
It changes color.
Yes, which changes color.
And is red, but in an alkali solution it turns blue.
In an acid solution, it is red, but in an alkali solution, it turns blue. Thank you, Hannah.
Yes, can I go to the bathroom?
Yes, you may. Okay, so now we're going to do question number 2. Are you done with question number 1? Should I wipe it?
Yes.
All right. Let's go to question number 2. This is where we're going to use the color. We're going to use the color. Now we have this table, and this table changes. This table shows us the changes that happens to those indicators when they are exposed or reacting with an acid or an alkali. Okay, so the litmus, we know that when you add an acid to it, it turns red, and when you add an alkali to it, it turns blue. The methyl orange, which is originally orange, turns red or pink when it is reacting with acid, and it turns yellow when it reacts with alkali. The red cabbage juice, which is purple originally, it turns red when it is reacting with acid, and it turns green when it reacts with an alkali solution. All right, so now we have different solutions. First one is the hydrochloric acid. The second one is the sodium hydroxide. The third one is the hydrochloric acid. The fourth one is also an hydrochloric acid. So they're only using hydrochloric acid and sodium hydroxide, but they want us to see how will they react with the different indicators. Okay, now let's see the first one. Who will answer the first one? Who will tell me what is the color change in the first beaker? What is the color change? We have a hydrochloric acid, and we want to know how will it affect the red cabbage juice. We want to know how will it affect the red cabbage juice. Hey.
It will become
No. Raise your hand. Raise your hand. Raise your hand. Okay. Yes, Mariam? Hydrochloric acid with the red cabbage.
Hydrochloric acid with the red cabbage.
Yes. It will turn what? Mariam, are you talking?
This is lagging.
Mariam, are you there? Mariam? There is something wrong with the voice, Mariam. Yes, can you hear me?
Yeah.
It will turn what? The hydrochloric acid with the red cabbage. It will turn what?
Green.
It will turn what, dear? Are you thinking or are you trying to tell us?
You miss.
Oh,
It will turn.
look at the table, dear. The red cabbage, if you add an acid to it, it will turn what?
Red.
Yes.
I said red at the
I
beginning.
couldn't hear you. I couldn't hear you. So we're going to color this solution red. Okay? You're going to color this solution red. Okay. The next one is the sodium hydroxide in litmus. The sodium hydroxide and the sodium hydroxide is an alkali, of course. So what will be the color change? What will be the color change? Yes, Ruqayya. Yeah, I know, Yasin. We're going to finish this and we're going to end the session. Hey, make it quick, Ruqayya, please. The
Blue.
it will turn blue. Very good. It will turn blue. Okay. So we're going to color this blue. Very good. Okay. The next one, hydrochloric acid with methyl orange. Hydrochloric acid with methyl orange. Yes, Limar. 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 Are you there? Yes, Yasin. Hydrochloric acid with methyl orange.
Red.
It will turn red. Very good. It will turn red. Okay, thank you, Yasin. The next one, hydrochloric acid in litmus. Hydrochloric acid in litmus. Yes, Najat. Hydrochloric acid in litmus.
Hydrochloric acid. Red.
Red. It will also turn red. Very good. Thank you, Najat. The next one, sodium hydroxide with methyl orange. Sodium hydroxide with methyl orange. Okay, let me finish it quickly. The sodium hydroxide with methyl orange and alkali with methyl orange will turn it yellow. Okay, it will turn it yellow. So you're going to color this yellow. And the last one, sodium hydroxide with the red cabbage juice, it will turn it green. It will turn it green. So you're going to color it green. Okay, guys?
Okay.
All right.
Okay.
So I'm going to revise this again next week to see if you did it right or wrong. and I will be seeing you next week, guys. I will do the assignment today. I know that I didn't put the assignment for yesterday's homework yet on Classera, so I will put it.
37, right?
What?
Okay.
It was page
37?
37. Yes, I'm going to put.
37. I did not see it.
Yeah, I will put the assignment today. It's written on Moodle. Okay. I
Okay.
have to go.
Bye.
Be seeing you next week. Bye bye.
Bye.
Bye.